Hi there, Mr. Sutton here, bringing you the IM3 Chapter 2, Quiz 1 Extra Practice Solutions on Basic Factoring. To simplify this one, we're going to have to multiply 3b squared by this parentheses, which means we have to distribute it to each term in here. 3b squared times 7b, that's going to be 21b to the 2 plus 1, because we're adding the exponents here. So that's 21b cubed. And then 3b squared times 3, that's going to be plus 9b squared. For this problem, we have to simplify by multiplying these binomials together. So a few ways to think about this. When all is said and done, you have to multiply everything in this first parentheses by everything in this second parentheses. A lot of different ways of thinking about it. So the order of multiplication, we use the acronym FOIL to represent it. We have the firsts, and then the outers, and then the inners, and then the lasts. But basically, you're just taking 3a, distributing it to this parentheses, and then doing the same with negative 2. So we've got 3a times 2a, that's going to be 6a squared. 3a times 5 is going to be a positive 15a. Now we do negative 2 times the second parentheses. So negative 2 times 2a gives us negative 4a, and negative 2 times 5 is negative 10. And then we look to see if there's like terms to combine. It looks like we have these two a terms in the middle. 15a minus 4a gives us 11a, and then nothing else has changed, so that's it. To simplify on this problem, I need to multiply these two parentheses together. I'm going to have to use the distributive property here. Specifically, I'm going to be multiplying both 6v and 7 by everything in the second parentheses. So just to take an extra step and write out what I'm actually doing, I've got 6v times that whole second parentheses, plus I have 7 times that whole second parentheses. So there's a total of 6 multiplications that need to happen. Now I'm just going to use the distributive property on each of these. So we have 6v times 12v squared, or 2v squared rather, becomes 12. And then we have a v times v squared giving me a v cubed, because we're doing 1 plus 2 for the exponents. Next, we have 6v times 7v. That's 42v squared. 6v times 4 gives us 24v. And then we have 7 times 2v squared is 14v squared. 7 times 7v is plus 49v. 7 times 4 is 28. And at this point, we collect our like terms. 12v cubed is the only cubic term, so we just bring that down. 42v squared can be combined with 14v squared because they have the same variable and exponents. So that adds up to 56v squared. We add the coefficients and keep the variable and exponent the same. Next, we have 24v and 49v. Adds up to, 73v. Careful with that one. And then 28 we're just going to take down because there's no other constants to combine it with. For this problem, we're dividing this polynomial by this monomial. So because I'm dividing each of these things by 8b cubed, because I got this plus here and everything's being divided, I can basically just divide each of these things individually by 8b cubed, which is to say I can give them their own personal 8b cubed denominator. So I'm going to have 32b to the 4th over 8b cubed, 24b cubed over 8b cubed, and so on and so forth. Everyone gets their own personal denominator. Now I just go through and simplify each fraction. 32 over 8 is 4. B to the 4th over b cubed. We're going to subtract the exponents. So that's going to be b to the 1st. So then 4b when all is said and done for that fraction. For the next one, these b cubes cancel completely. 24 over 8 is just 3. And then we have 16 over 8 is 2. B squared over b cubed is going to leave us a b in the denominator because 2 of these 3 b's down here got canceled out with the b squared up here. So then we end up with 2 over b for that fraction. For this one, we're trying to factor this expression. We always check to see if there are common factors we can take out. So 50 and 30, those both have a common factor of 10. And then between u to the 4th and u squared, we can take a u squared out of that. It's always, if you have the same variable, it's always the lowest exponent is the greatest common factor. So we have a 10 and we have a u squared that are coming out. And to do this now, we're just going to divide each of these terms by 10u squared and put the leftovers in a parentheses. So 50u to the fourth divided by 10u squared, that's going to be 5u to the second. We're going to subtract the exponents. And then 30u squared divided by 10u squared. U squareds are completely canceled. 30 over 10 just gives us 3, so this is just plus 3. To factor this problem, we first look to see if there's any common factors we can take out of all 4 terms, and it doesn't look like there are. We can take a 3 out of the first 3 and a 5 out of the last 3, but there's nothing that works for everything. Same thing with variables. We've got some x's, we've got some y's, but all 4 terms don't have the same variables. So we go on to the next thing, which is looking at factoring by grouping. Since we have 4 terms, grouping is always a possibility. Let's look at the ratio of the first 2 and the last 2 terms to see if grouping would even work here. So for the first ratio, we have a 9 to 15 ratio. That reduces to 3/5. The second ratio, we have 15 to 25. That also reduces to 3/5 if you reduce both of those by 5. Since we have the same ratios, we can actually try grouping on this. So let me take a common factor out of the first 2 now. They're both divisible by 3, and we can also take an x out of both of those. So 3x comes out. 9xy divided by 3x leaves us with a 3y for that first term. And then negative 15x over 3x, that's going to be minus 5. Next, out of the last 2 terms, we can just take a 5. And that leaves us with a 3y minus 5. Since these parentheses have the same exact thing in them, they are considered a common factor that we can now factor out of everything. So 3y minus 5 comes out as its own common factor. And then the leftovers, 3x plus 5, can be put in parentheses next to it. For this problem, we're trying to factor a trinomial that has a coefficient, a squared coefficient of 1. In situations like this, we can just find factors of the constant that add up to the middle coefficient and put those factors in parentheses with the variable. So on this one specifically, I'm looking for factors of negative 18 that add up to 7. Now I can do a little sign analysis. Since my factors multiply to give me a negative, I know they have opposite signs. So let's look at some factors of 18. We've got 1 and 18. Those will not add up to 7 or subtract. I have 2 and 9. Now if I had negative 2 and positive 9, that would add up to positive 7. So my factors then are going to be n minus 2 and n plus 9. To factor this trinomial, I'm going to need factors of 27 that add up to negative 12. I know since the constant here is positive that my factors, since they multiplied to give me this 27, they must both be the same sign. And since they add up to a negative 12, they must both be negative numbers. So factors of 27 that we can consider, well, there's 1 and 27, but that doesn't add up to 12. There's 3 and 9. That does add up to 12 if you have negative 3 and negative 9. So then m minus 3 and parentheses m minus 9, those will be our factors.